Okay, welcome to section 8.5. We're going to be adding and subtracting rational expressions today. And the essential understanding that you need to understand is that when we add or subtract rational expressions, you need to first find a common denominator. And when we look for the common denominator, we're really looking for the least common multiple. Just like when you add or subtract fractions, you need to find a common denominator. And one way you can do that is by multiplying the denominator straight across. But that might not be your least common multiple. So again, we're going to look for a common denominator and look for the least common multiple. So here's our first example, problem 1. It says, what is the least common multiple of 2x plus 4 and x squared minus x minus 6? So there's two steps that we need to apply. Number one, we're actually going to prime factor each of these two expressions. And secondly, we're going to take the product of primes raised to the largest power. And that's key, product of primes. So when we look at 2x plus 4, we see they have a common 2. So you factor out the 2 and we're left with x plus 2. Now for the quadratic piece, when we go ahead and factor this, two numbers that multiply to be negative 6 and add to be negative 1 are negative 3 and positive 2. X minus 3, x plus 2. These are prime factors because we cannot break them down anymore. There's nothing common in this binomial other than 1. Same thing with this binomial and this binomial. So that's step 1. Prime factor each expression. 2, you have to take the product of these primes raised to the largest power. And the key is, if you see a repetitive binomial, a repetitive prime, you don't put it twice. You just do it once, but you raise it to the largest power. So I see 2, that's prime, that comes over here, times x plus 2 and x minus 3. Notice I don't have x plus 2 twice here. I just have it once because the largest power on each of them is 1. So it's the product of primes raised to the largest power. Don't repeat your prime factors. So problem number 2. We're going to find the LCM of three terms this time. X squared plus 3x minus 4, x squared plus 2x minus 8, and x squared minus 4x plus 4. So now there's three terms that we're looking at, and number 1, like we did in the last example, prime factorize what you can. All three quadratics, it just so happens, are factorable. So the first one here, x squared plus 3x minus 4, factors into x plus 4 times x minus 1, the prime factors. We have x squared plus 2x minus 8, so that factors into x plus 4 times x minus 2. And the final problem here, the expression x squared minus 4x plus 4 is actually a perfect square. It's x minus 2 squared. So the least common multiple are each of these prime factors taken, and they take the largest power. So we have x plus 4 and x minus 1. We multiply those together. Don't repeat this x plus 4. Okay? We see x minus 2. So that's going to come down. But if we notice here, we have x minus 2 and that's squared. So we ignore this one and we take x minus 2 raised to the largest power. And that's what they mean by taking the product of primes to the largest power. We factor all of our terms, take all the prime factors and multiply them together. If we have a factor that repeats, such as x minus 2, you take the one that has the largest power and that comes down. And that's how we find the least common multiple. So what do we do with the least common multiple? Well, we're going to add or subtract these rational expressions. And so the first example, what we're going to do is we're going to add two rational expressions. And to do that, we find the least common multiple. So we look at our two denominators and we see that one could possibly be factored. So I rewrite my rational expression and I try to factor. These are both prime. so I can't factor. But if I look to the second rational expression, I can factor the denominator, and that's what I've gone ahead and done here. Two numbers that multiply to be 2 and add to be minus 3 are minus 2 and minus 1. So the common denominator would be the LCM. It would be x minus 1 times x minus 2. So just like with adding fractions, how do we add these rational expressions? Once we find the common denominator, we see that this first rational expression is only missing the x minus 2. So both the numerator and the denominator get multiplied by x minus 2. Plus, here's our second rational expression. That actually has both pieces of the LCM. So we don't multiply the second rational expression by anything. So what we do here now is we cross multiply x times x minus 2, which is x squared minus 2x, plus 2x minus 1, all over the LCM, which is x minus 2 and x minus 1. Remember, this LCM came from factoring our denominators and taking the prime factor of both terms to the largest power. X minus 1 does repeat, but both are powers of 1. And the x minus 2 is also a prime factor and comes along for the ride. The first fraction was missing the x minus 2, so again, that got multiplied by x minus 2 to the numerator and the denominator. So here's what we're left with after we distribute that x in the numerator, and we're going to leave the denominator here. So we see that 2x and minus 2x cancel out, and we're left with x squared minus 1. And that's divided by the LCM. We're not done. Right here, you should notice x squared minus 1 is the difference of two squares pattern. So what we're going to do is go ahead and factor the numerator. X plus 1 and x minus 1 is the pattern for x squared minus 1. And we notice here that x minus 1 and x minus 1 become 1. They cancel out. They're common factors. So we're left with x plus 1 over x minus 2. The last thing that we have to worry about are the restrictions. X can't be 2 and x can't be 1. So we have to include those restrictions here as well, or else those won't be equivalent. This sum will not be equivalent to this if we forget the domain restrictions. Our final example, problem 4, is going to be very similar to the addition problem, yet this time we're going to be looking at subtraction. So again, we look at both rational expressions and try to factor. The numerator can't be factored here, but we notice in the denominator we have a common x. So we factor the x out, and we're left with x times x minus 2. Okay? Minus, we have x plus 2. That can't be simplified. But if we look at 2x minus 4, that has a common factor of 2. So the LCM, the least common multiple, becomes 2x times x minus 2, multiplying all the prime factors together, and if there is a repeated factor, taking the largest power. X minus 2 repeats here and here for the LCM, but the largest power is 1, so that's why we only see a first power. X is prime factor, that comes along, and the 2 also comes along. So how do we simplify that? Let's look at the first rational expression. Now, you have to look at this and say, well, if the LCM is 2x times x minus 2, you have to ask yourself, what is this missing out of the LCM? And it's missing the number 2. So the numerator and denominator both get multiplied by 2. Now, the second rational expression is just missing the x. You notice 2x times x minus 2. So the second rational expression is missing that x, and that's why this second rational expression gets multiplied by x over x. Now, we multiply the numerator, we distribute the 2, so 2 times x is 2x, 2 times 2 is 4, minus x times x is x squared, and x times 2 is 2x. Notice how we have the subtraction sign for both x squared and minus 2x. You could also have done the plus and minus here as well. Adding a number is the same, subtracting is the same thing as adding the negative. So once we have this rational expression, we've distributed the 2 in the numerator and denominator, we have a common LCM. Okay, we can add like terms. So you have negative x squared, 2x plus negative 2x is 0 x's, and we have plus 4. So we're down to just negative x squared plus 4 for the numerator and 2x minus x minus 2 in the denominator, which is the LCM. You might think we're done, but you have to be careful. We're going to factor out that negative. So we're going to factor out negative from the x squared, and we're going to have x squared minus 4 all over the LCM. Now we have a difference of two squares pattern in red. So that becomes x plus 2 and x minus 2. Now look what happens here. You have a common factor again in the numerator and the denominator. Those become 1. So we're really left with the opposite of x plus 2 over 2x. Now we know that x can't be 0, but if we look back here, x can't be 2 as well. So there, the last step is to look at the domain restrictions. So that is adding and subtracting rational expressions by using the least common multiple. I hope you learned a lot. If you have any questions, you can email me. Don't forget, you can always stop, rewind the videos, and go at your own pace. We'll see you for the next video.